Welcome back. Today we are going to talk about how we can create phase sets. Phase sets can be used to assign boundary condition or to have any kind of arbitrary mesh interface. For that you need a master phase as well as a slave phase. You can create these phases using phase sets, and for that we have to use topoSetDict. We'll see that how we can do it using this following example. I'll first run blockMesh and show you that what kind of mesh we have right now. This particular mesh has 5 zones, zone 0 to zone 4, and there is only one patch. Basically all the outer faces are clubbed into one default face because we have not assigned any particular label to any face. By default everything goes to default faces. Let me open VS Code and show you what is going on here. Here I have defined my block mesh as this. If you don't know how to define a block mesh, you can go back and watch one of the tutorials that is present in our YouTube channel on creating a block mesh and what are various things that you have to define to create a block mesh. First, I have defined the vertices. Vertices are these many. Using those vertices, we can create blocks. These vertices should not repeat. If they are repeating, then a new region will be created. For example, this particular region, which is the top layer, is using these vertices, but this 43, which is here, is the same coordinate as some other coordinate previously defined as well. This is 1.1, positive 0.02 and negative 0.15. You can see this is same as here. 0.15 is same as 0.43. Since they are same, if we use for one of the hex we use 0.15 and for another block we use 43, then we'll get two different regions. Here are the name of the regions that you can always use to define particular regions. These will be helpful while creating sets like cell sets or phase sets. You can define the regions so that it selects the cells or faces from that particular region only. Then I have not defined anything, any edge or any boundary. Here you can define all the boundaries that you have. If you write points in a manner such that the normal of that particular face points outward, then it will be correctly defined and then you can assign a label to that. But that is difficult. So today I'll show you along with this that how you can choose an external boundary. I'll also show you that how you can choose an internal boundary and make it face zone or face set. Let's get started. I'll first create a topoSetDict. It's already created here, so I'll remove this existing one, which is system topoSetDict. I'll remove this one, and also I'll remove the create patch. And again, I'll go back and create a file topoSetDict. In this topoSetDict, I first need these headers and then a series of actions. These actions take place in the order we define them, and then I can create a cell set first. Using those cell sets, I can create faces. First, creating a cell set was also described in my previous tutorial. You can just go back and look at that how we can create a cell set. Let me use a name here. We also have to look at what regions we have. Let's create the top layer. From the top layer, we'll create the top layer cells. Name, top layer cells. Type is cell set. Action, we want a new cell set. And then source is zone to cell. And then the zone name is this top layer. Now, let's see if this zone is created or not. We'll just run toposet. You should have a semicolon at the end. So you can see it created a cell set with the name top layer cells and then applying source zone to cell, then adding all cells in the cell zone top layer. We can also do foamToVTK and write here cell set and then the top layer cells. Now I can open OpenFOAM. You can look at the geometry as well. The geometry looks something like this, which is similar to flow past a square cylinder. But when you look at here, you can see that there are different zones This is one zone, this is another zone, and there's a mismatch because we want a interface here. Similarly, here also they are not aligned because there's an interface in between these. This entire layer is an interface. Let's open the zone that we have created, the top layer cells. If I switch this off, you can see that the top layer has been selected. Let's see how we can select a face. I want to select all the faces here. In order to create an inlet face, I can say that I want to create a face set by the name inlet, and the type is face set, action is new, and the source is normal to the face, and the normal direction is -1, 0, 0, and the cos angle you can set to anything. Let's see. So again I have to create the block mesh and then do toposet. It selected 375 faces. Again let's do foamToVTK, and I have to do here face set, and again visualize this. Now here you can see, let me open the inlet as well. We have face set, inlet. So you can see that along with this face there are some other faces which are pointing towards the -1, 0, 0 direction. Let's see how we can remove those. Let's first look at the source code as well, what is going on in the source code. Let me open the source code. In the source code, if you go to this face sources, there are various methods. The previous one that we have selected was using normal to face. This is how you can select. These are the mandatory entry. You have to put a name, then type, face set, action. Action can be new, add, subtract, and there are some derived actions as well. For example, invert, subset, and others. Then the source you should always write normal to face. Normal you can change to whatever. Cos is the limit. It is the tolerance angle. In this manner you can select. So it selected all the faces which are pointing towards this and has this much tolerance. Now I can use box to face to select the faces in that particular box. So I can do this, name inlet, and then type again face set, but the action is subset. Source is box to face. The domain starts from -0.3 and goes to 1.1. If I select something starting from -0.31, -0.31 to anything bigger than the domain, let me choose something like these 2 points, and then the other point is little bit away from -0.3, which is -0.29, then again 0.5 and 0.5, a big value which covers the entire domain. Again run toposet, first run block mesh and then toposet. You'll see that out of 375 it selected 75, and again if I do foamToVTK and then visualize this, here you can see that only the inlet face has been selected. Now how to create a boundary label using this. In order to do so, you have to create another dictionary which is called createPatchDict. Similar to topoSetDict, you should have all these headers and then patches. Inside those patches you can define patches in any order you want. First thing that you have to do is name the patch. One name is inlet, and then you have to provide some patch info. Patch info contains information like the type. Type is a patch. It's a standard patch. It can be a wall, it can be a cyclic AMI, it can be something else as well. If there is anything else you can define, but if there is nothing, then you can just write that we want to construct this from a set. What is the set name? Set name is inlet. If you go to constant polymesh and boundary, you will see only default faces. Now let me run this, create patch, and remember to override. If you don't override, then it will create another mesh. There was some problem. Let me just check. Construct from this patch info patches. This whole thing should be inside the dictionary. Create patch has this standard format. You don't have to write much here, except if it is an AMI, then you have to define other things, for example the transform, the match tolerance and all. If I run this now, it has created a face. From the face set it created a patch. Let's see how the boundary has changed. In the boundary you can see there is a new patch which has been created, and from the default faces it removed some of the faces. This is how create patch works. It creates patch depending upon the face set or some other criteria. For example, a patch, you want to convert that to a AMI. You can do that using create patches. Now let's see how we can create phase zones which are required to create some kind of boundary conditions which are not standard like inlet outlet. If you want like moving mesh or something like that, then you should have information about the master and slave part of those phases, and for that we need phase zones. Phase zones are similar to this. You can always convert a phase to a phase zone. Let me open the mesh and show you that which particular phase I'll convert to a phase zone. I'll open ParaFOAM, and here I'll convert this particular phase which is in between this particular region and this region. There's a phase here. I want to convert this to a phase zone. I'll first create a phase set, then I'll create a phase zone. In order to do so, I'll first write name and then name as mid left layer and the right side of that. For the left layer, the right side of this. The type is phase set, action is new. First let me create a cell set. From a cell set I can create a phase set. I'll first create a mid left layer cells. Type is cell set, action new. Source zone to this, and the zone is mid left layer. Let me just check if it is correct. Mid layer left. This layer I want, and from this I can create cell to faces, and then the set is this. And here I can choose option. Options are required if I want everything, all the faces, if I want just the outside faces or the interior faces as well. I just want the outside faces. I'll select outside. From this I can create a subset. Name same as middle left layer, type face set, action is subset. Then the source is normal to face, and the normal is -1, 0, 0, and cos I can again select this. Once I have created this, I can convert it to a phase zone by saying this. I can create mid left layer left, and then type is phase zone set. If I go to the source code again, you can see that you can have a phase zone source. Here also you can have different kinds. Here I have from set to phase zone. Here I can select only one set like a phase set, or I can have sets. So I'll select sets to phase zone. Sets to phase zone. Here I can have a phase set and a cell set as a source. If there's a typo here, it should be sets to phase zone. The phase zone, and then action is new. Then source is sets to phase zone. Then I'll select a cell set and a phase set like this. Now let's see what we have now. Block mesh, and then again topoSet. There was some problem. It did not select anything here. Mid layer left, mid left layer, mid layer left. There was a typo here. Mid layer left. So it created inlet, then it created this mid layer cells, all the 375, and then mid left cell to face. It created all the added faces according to the cell set. For all these, it selected all the faces which were the outside faces, and then there was some problem. I cannot find this layer right. Again, let's run topoSet, and here you can see it created this eventually phase zone and phase set. Let's do foamToVTK. The phase zone of this phase zone is not an option. Let's just check the phase set is created or not. You can again open this, and then in the VTK you can go here and check if the phase zone is created or not. So mid left right, and when we switch this off, it selected this one, but we wanted the other direction phase. That means we want this one. So again, to block mesh, and foamToVTK, again open. So now it selected the correct face. You can also do this wireframe and check it selected the correct face. This face, now you can put some kind of mesh motion here. You can move this entire patch as is and then make some refinement in this particular zone. These kind of faces are helpful in those cases. Let's stop here. In the next lecture, we are going to learn that how we can use phase zones to create a certain kind of boundary condition in which we can move this particular domain in the forward direction and make these two interfaces, this one and this one, to have a arbitrary mesh interface and perform a simulation of moving squares in a domain. If you like the content of our channel, then you can like, share and subscribe. Thank you.